6 still less than 99? Okay? I can add whatever I wanted as long as the inequality holds true. Okay? So right now what we have to do is we have to get out of the mindset of working with the addition property of equality. Okay? Because we're not dealing with equalities, we're dealing with inequalities. So what we have to do is we have to add something to both sides of this inequality that's going to both remain true for the inequality, but also help us to get to k plus 1. Okay? Now, let me give you guys a hint on this one, so that way maybe if you guys saw a secondary example, you get help. I'm going to add 2k, and what I'm going to do on the left side is I'm going to add 2 on the left side, and on the right side, I'm going to add 2 to the k. I should have put that in blue. Since I have this fancy blue marker. All right. Now, before I even talk about why I did that, let me make sure that you guys understand that that is legal and why we can do that. Okay, so let me ask you guys, is 2 less than 2 to the k provided that k, and remember, n equal k, is it true as long as k is bigger than 3? That's true, right guys? Because what's the smallest value that 2 to the k could be?
0.
8 for this one, because k is 3, right? At least it's 3, right? So I know that 2 is less than 2 to the k for all k bigger than or equal to 3. And that's our domain restriction. Okay, so that's my justification as to why I can do that. Okay, so let's write up here why we can do that. This is legal since 2 is less than 2 to the k for all k bigger than or equal to 3. Okay? Now it's not true if we use something like 0 or 2, or 0 or 1 or -5 or something like that. But remember, our original problem says for all n, and we said that n is equal to k, which means it has the same transitive domain. All right, so everyone believes me that at least you could do that. Now, why didn't I put 3 in here? Why did I put -17? Why did I put e in here? Why did I choose the specific value of 2? John?
So you can factor out the 2 and add your k plus 1.
Okay. Guys, isn't it true I could factor out a 2 here and get k plus 1? Okay, so this would be 2 quantity k plus 1 plus 1, right guys? Doesn't that say that what I did was I inserted or I built the k plus 1? Because instead of having a coefficient of k, 2 now has a coefficient of k plus 1. Okay? So we built the k plus 1th term. On the right-hand side, I have 2 to the k plus 2 to the k. Guys, can't I combine those? Aren't those like terms? What would that turn into if I added those together?
So
2
times
2 to the k's, right?
Yeah.
Okay, just like if it was x. This would be 2 times 2 to the k. Okay? And that's just by that's just by GCF and like terms. Okay, so this step right here, GCF / like terms. Guys, what do we know about 2 times 2 to the k? What's another way to rewrite that?
1 plus 1.
No, no.
You could, okay, you're right, Don.
Two-
What's a way that'll help us to get to the k
It's
plus
2
1?
to the power k plus 1.
Yeah. Guys, doesn't this have an exponent of 1 attached to it? When you have like bases, couldn't you add them together and just write that as k plus 1? Okay? So, I'm going to do that. So this now becomes 2 quantity k plus 1 less than 2 to the k plus 1. That's just by exponent rules. And now what we've done is we've built the k plus 1th term. In the inductive step, we had 2 times k plus 1. Now we have 2 to the k plus 1 plus 1. On the right-hand side, we had 2 to the k initially. Now we have 2 to the k plus 1. Okay? Before I finish this off, what's the hard part about this problem? Yeah, figuring this stuff out, right guys? What I wrote in blue. Because it could be anything, couldn't it? I mean, it literally could be, like, I could put 1 over here, and I could put 3 to the k over there, and that would still be true. So the sneaky part about this is knowing the correct stuff to add to both sides, okay? Now I'm going to show you guys some hints to be able to do that.
Did you
Okay?
pick 2K because you knew that you could eventually do the 2 times 2K?
Correct.
So you want to be just mindful of what works.
You're exactly right. You want to think ahead, and you want to think to yourself, when I add these together, it better end up being the same base as what we had with the k. Okay, that's probably the way we're going to think about this. And I'll help you guys to see a little bit better in another example with this. Okay, so it's definitely sneaky stuff. Okay. All right. So any questions before we finish this one off? We're almost done with this, obviously. Okay. And thus what we've done is we've built the k plus 1 terms. So we can say by basis and inductive steps. So therefore, there's no definition to use because we've proved it true for the k plus 1 term. So by basis and inductive steps, the result holds. All right. Yeah, I know, exciting stuff, right? All right. So, any questions, guys, I can answer about this? Okay, I want to work one more with you guys, okay, and then I certainly want to make sure I have some time to review for the examination with you. But I want to show you what happens if we have 2 exponential expressions in our inequality, or another one, I'm sorry. Here's another one with a polynomial. In fact, let's skip this one, and I will post the solution online to this. If I forget, somebody email me and remind me, okay? What's that? Well, as long as you guys email me, I'd be happy to do it. Like, or you emailed me, and I think I did it like 5 minutes later, okay? But I've got like 1 million people asking me for 1 million things, so it's easy for me to forget things. Not on purpose. It's not like I'm trying to be a dick. It's forgetting on purpose. All right. So let's go ahead and verify this number 10. And maybe you guys can see like a trick to be able to figure out what to add to both sides. And I want you to notice, guys, these proofs aren't long. They're just kind of taxing on the brain. Okay. So let's go ahead. We'll do the easy stuff first. Okay. Let's let n equal to. So we get 5 squared plus 9 is going to be less than 6 squared. Or in other words, 34 less than 36, which is true. Basis step holds. For small values of n. And then we're going to assume the result holds for all n equals k, create an integer. Thus, 5 to the k plus 9 less than 6 to the k. So that's the easy stuff. I want to knock that stuff out so that way we can focus on the more difficult stuff. Okay. Now, going back to last proof, okay? With the last proof, we didn't use substitution, and we're still not going to use substitution, okay? Again, every time we have an inequality, what we want to do is we want to build the k plus 1th term, okay? So, we're just going to use induction, and we're going to say, okay, well, I already know it's true the previous step. Okay, so we're going to say that by induction, 5 to the k plus 9 is less than 6 to the k. So that's by induction. All right. Now this is the hard part of the problem, where we have to figure out something to be able to add to both sides that's going to do 2 things. It's going to keep the inequality true, but it's also going to get us to the k plus 1th term. So maybe somebody knows what we can add to both sides of this, okay? It's not going to be 5 to the k and 6 to the k, okay? Because that's not going to give us enough to get to where we're going, okay? So, does anybody think they might know what we have to add to both sides of this? And I bet you if I do the first one, I bet you somebody else can figure out the right-hand side of this. You're really close, okay? You're just off by 1. For the left-hand side, let me, okay. So, Greg, you said for the right-hand side, you're going to add 5 times 6 to the k. In fact, let me put that in blue, so that way everybody can see what it is that we're actually adding. Guys, what happens if you add 6 to the k plus 5 times 6 to the k? How many 6 to the k's do we get? 6 to the k's, right? So doesn't it seem like it might be logical for us to add 1 less than the base for the coefficient on each side? So for the right-hand side, or for the left side, what could I add to the left-hand side to keep the inequality true, but also make sure that we get to 5 to the k's?
4,
4 5 to the k's. Okay, so this would be 4 5 to the k. Alright. Does everybody see what we're doing, guys? It's almost like an algorithm. The coefficient is going to be 1 less than the base, because that way when we add them together, we get 5 to the k's, and then 6 to the k's. Okay? What if we had like 98 to the k? Wouldn't we add 97 times 98 to the k? Okay? So you just add on 1 less to each side for those. Does that make sense to everybody, guys? It's not too difficult once you guys see the process of this. Okay? I'll fill in the steps. Oh, by the way, let me ask you guys, is this legal? I mean, does that always work? Yeah. Because isn't it true that, remember, our domain was k greater than or equal to 2, and I know that if I plug in 2, 3, 77, this guy's going to get bigger than this guy much quicker, okay, just because the numbers are quicker, okay, or they get bigger quicker, okay? So this is valid since 4 times 5 to the k is less than 5 times 6 to the k for all k bigger than or equal to 2. Okay. Now, we're not going to prove that. If you wanted to prove it, you could use a ratio test. Okay? Yeah, no thanks. We'll avoid doing any sort of infinite series test, won't we? Okay. But at this point, guys, we just combine like terms and we're done with this. Okay? I have 5 to the k and 4 5 to the k. If I combine these just by like terms, that becomes 5 to the k's plus 9. On the right-hand side, 1 6 to the k plus 5 6 to the k's becomes 6 to the k's. Okay? That's not going to end up being like 36 to the k or anything like that, because we're combining like terms, we're not multiplying.
Can you explain that on the left side again? Whatever happened to the 4? What's
Okay.
going on there?
Andre, think about this. Like, hold on one second. Let me make sure I'm specifically answering your question. Are you asking, like, what happens when we combine these, and we got 5 to the k's? Or are you asking, why did we add 4 times 5 to the k? Both, okay. We need to be able to add something to the left-hand side, so that when we combine like terms, we get 5 to the k plus 1. Okay? So what I'm doing is I'm just adding 1 less than the base. So 4 times 5 to the k. Notice over here, 1 less than 6 is 5. So that way when I add these up, if I have 1 6 to the k and 5 6 to the k, that gives me 6 to the k's. Okay? There's a coefficient in front of this that's imaginary, like a 1. There's a coefficient that's imaginary, that's a 1. So you know that 1 plus 4 is 5. 1 plus 5 is 6. Okay? Just think of these like x's, if you would. Okay? And it might help you to see like 1x and 5x is 6x. Okay? Does that help a little bit?
Yeah.
Okay. And it's always going to be the case with these inequalities that you do that. Okay? Alright, that's just by like terms. And then we're done, right guys? Because doesn't this become 5 to the k plus 1 plus 9, which is less than 6 to the k plus 1. That's just exponent rules.
So when doing these problems, as soon as you see the power of n, you should first thing you think is I need to get the same amount of terms from the original coefficient.
Right, of the coefficient, right, so that way you can build that k plus 1 term. Okay? Yeah, that's probably the best way to think about it. Okay? our proof's done, we just say therefore by basis and inductive steps, result holds. Okay, so therefore, by basis, inductive steps, the result holds. Okay. So guys, any questions I can answer about induction with either divisibility or with regard to being able to work with the ones with inequalities? All right, so let me talk about what's going to be on the exam then for Wednesday with you guys, okay? The way I work the second examination is that the first 10 questions are going to be like really quickies. They're going to be 2 points apiece. And then the other questions, I'm going to have 6 proofs on there ranging from 10 to 15 points apiece. Okay? So let me talk about those types. And that sort of stuff. So, problems, or part 1, just some short answer stuff. Okay, so there's going to be 10 problems, 10 questions, 2 points each. Okay, so you could feasibly get all 10 of these wrong and still get a B on the test. Okay. Of course, that probably wouldn't be good because the proof stuff's the hard stuff. But just some examples as to what to expect to see. And most of these are going to be really easy for most of you guys. Okay. I might ask you guys to show, but not prove, show something like 37 is odd. Okay. Not prove it, but just show it's odd. Okay. Guys, how could you show that 37 is odd?
2 times 18 plus 1.
2 times 18 plus 1. There you go. Then you just got a 2 on the exam. That's literally, and that's what I mean by like the 2-point questions, okay? Those are like